Hello friends, today we are going to study the next part of the air pollution chapter. The next part, in the first two lectures we have studied about the what is meant by air pollution, what are the different types of air pollutants, then what is the dispersion of air pollutants, how the dispersion is going to be affect on the human being or the residential area. Then meteorological parameters, how the meteorological parameters are important to understand the effect of air pollutants. That part we have covered. Also we have covered the effects of air pollutants on the human being, materials, then animals, vegetation, etc. Now the next part and very important part we have to study in this today's lecture, and that is nothing but the control equipments. Control of air pollutants. How to control the air pollutants. So again I am going to repeat the same sentence what I told you in the first lecture with respect to air pollution, that air pollutants must be controlled at the source, because it is very difficult to find the pollutant into the atmosphere and separate them out from the atmospheric air. So we should take care with respect to air pollution to control that pollution at the source. Now how to control? In the specific industry, you can control by using the various devices the emission of particulate matter, and as especially particulate matters we can go to concentrate. So what are these equipments? So I will list here. The first one popularly we can use, that is nothing but the gravity settling chamber. Second one is the bag filter. Third one is the cyclone. Cyclone, or we can say cyclone separator. Then the fourth one is the scrubbers. Scrubber is basically used to remove the gaseous types of air pollutants. Then the next one is the electrostatic precipitator. Electrostatic precipitator. We can also call it as ESP. Okay, so these are the different equipments we can install in the industry before allowing to emit the air into the atmosphere. After the manufacturing process, whatever the dust is going to be created during the manufacturing process in an industry, that air will pass through the one or the sequence of one or more than one equipments in a series, and then it will emit into the atmosphere through the stack. Is it? Are you getting what I am saying? Suppose this is a particular industry, and that industry is having this as a stack. So in that, from that stack, the pollutants are going to be emitted into the atmosphere, and this, what we can call to this is the plume behavior. We have studied that in a last lecture, plume behavior. Now this plume behavior, so before reaching that air pollutants here, there may be the manufacturing process of something is going on in this industry, and during that process the air pollutants are going to be emitted, and that entire air has to be passed through the one or more than one equipments mentioned above in a series to remove the pollutants at the source, and then we can allow to enter that air into the chimney, and then it will pass into the atmosphere. So now you may have the question whether we should go for one equipment or more than one equipment, or which one equipment we have to select. Actually, each equipment listed here is having the different types of efficiency. We are going to study one by one, but as per the requirement how much amount of air is polluted, and what kind of air you want to be emitted into the atmosphere. Accordingly, you should decide whether you are going to take one equipment or number of equipments in a series. That depends on the meteorological assessment of that particular area. We can decide. Now we will see one by one equipment. So the first equipment is the gravity settling chamber that we are going to study now. So what is this gravity settling chamber? A gravity settling chamber is the simplest type of equipment used for the collection of particulate matter. You remember that? Whatever I will tell you, you should remember that particulate matter. In the last lecture I told you PM, particulate matter, or simply we can say it is a dust. How we can, there are the different types of dust, especially PM 2.5 and PM 10. What is this PM 2.5 and PM 10? So PM 2.5 is nothing but the particulate matter or the dust particles, the carbon particles whose size is smaller than 2.5 micron. And PM 10 is nothing but the particulate matter whose size is less than 10 micron. Getting? So accordingly, this can be identified. Now this equipment I am saying you, a settling chamber is the simplest type of equipment used for the collection of solid particles. That is nothing but particulate matter. Means what? This equipment is not going to be used for the gaseous pollutants. Is it? We are only using it for the removal of particulate matter. Now we will study that equipment with the help of figure. I will explain this. So this is the partial figure I have drawn already to save your time. Okay. So this is the settling chamber. Figure is the settling chamber, or we can say gravity settling chamber. Why we are saying gravity? Because the particulate matter in this type of equipment are going to be collected by the gravity. Gravity settling chamber. This is the inlet I have shown here. It is the horizontal. It is a simple, it consists a simple cylinder. There is one end, we can say it is an inlet, and another end we can say it is a outlet. Inlet for the laden gas. Laden gas in the sense impure gas which you want to treat, or which you want to remove the pollutant, from which you want to remove the pollutants. It consists of chamber. This is a chamber in which the carrier gas velocity is reduced so as to allow the particulates to settle out of the moving stream under the action of gravity. So I would like to tell you, this is the length of this gravity settling chamber. Absolutely, this is the height of the gravity settling chamber. The laden gas or the carrier gas is moving in this direction. Ultimately, it is having the velocity v, and here suddenly we are increasing the area, and because of that, velocity of the inlet or the laden gas is getting reduced. In that way, the particles present into this gas will start falling down in a hopper bottom. To this we can say hopper, which is used to collect the dust. It will start falling down by its weight, and that with the velocity, settling velocity Vs. Do you understand? This is the length of the settling chamber. This is the height of the settling chamber. This is the velocity of the gas, and this is the settling velocity of the particles or the dust which we want to remove. Now this is the simple structure, simple phenomena is there. Suddenly what we did, the diameter of the chamber has been increased. Meanwhile, the velocity of the gas is going to be reduced and the particles by its weight starts falling down. Is it? So usually the velocity in this settling chamber should not be greater than 3 meter per second and it should not be less than 0.5 meter per second. Why we should? For getting the better results, minimum velocity must be 0.5 meter per second. And why it should not be greater than 3 meter per second? There is a possibility to, if we will increase the velocity more than 3 meter per second, there is a possibility to have the re-entrainment of the particle. Whatever the settle, it will also be getting float now. That is the re-entrainment. We can say this is the re-entrainment of the particle. So to avoid that, we should take care of that. It should not be greater than 3 meter per second. Now we will see when the particles are going to be settled down into this. This structure you can construct by using the bricks and cement. Usually it is better to go for the construction with this brick and cement instead of using the metals, because metal, with respect to metal, there is a issue of corrosion because the laden gas is contaminated with various impurities and there may be the corrosion. So better to go with the such type of material, that bricks and cement you can use. Then now where the particles are going to be settled down, how the particles are going to be settled down. As I told you, the gas velocity should not be less than 0.5 meter per second and it should not be greater than 3 meter per second. A simplified analysis of the gravity settling chamber assumes that the solid move along the chamber. Solids move along the chamber with the velocity of the gas v, as I have shown here. Then also settles with the Stokes velocity, that is Vs. The particle which is entering into this chamber is going to be settled only when the particle, this particle you can assume, which is going to be settled only when its a moving velocity equals to the settling velocity. Then only the particle are going to be, at this stage the particle will settle down. So some particle may settle down here, some particle may settle down here, some may settle here, or some may go to settle here. It depends upon each size and shape of that individual particulate matter. So but when it is going to be settled down? When the V, moving velocity of that gas, is equal to the settling velocity of the particle. In that case, the particles are going to be settled down. So the same thing mathematically we can write when the particles are going to be settled down. How we can write? That is H upon Vs is equal to L upon V. Is it? This, when it is getting equated, the particles are going to be settled down. So from this equation I can find out the equation for Vs is equal to H into V upon L. This equation we will assume as a first equation. Okay, this we can find out in that L is the length of the length of this chamber, V is the velocity of the gas, H is the height of the chamber, Vs is the settling velocity of particulates. But what Stokes' law states? By Stokes' law, what Stokes' law states? Stokes' law states that Vs is equal to G into rho s minus rho into d square upon 18 mu. In that G is nothing but the acceleration due to gravity. Then rho s is nothing but the density of particle, or we can give the notation as a rho p, density of particulate matter. Rho is the density of gas, mu is the viscosity of gas, and d is the diameter of the particle which we want to be removed from the gas. Is it? Then this we can say this is the equation number 2. Now we will equate both these two equations and we will find out. Equation number 1 and equation number 2 we will equate. Now HV upon L is equal to G into rho P minus rho into D square divided by 18 mu. When you will equate this equation and solve further, you will be able to find out the equation for D, that is diameter, and that equation I will write here directly, simplified equation as 18 mu into H into V upon Lg into rho P minus rho brackets raised to 1 by 2. That will be the equation as a third equation we can say. So from this equation we can find out which diameter of the particle is going to be removed with respect to these dimensions of the settling chamber. Are you getting? This equation will help us to find out which diameter particles will be removed from this particular dimensional settling chamber. Are you getting? So this is the one of the equipment which we can use to control the particulate matter. Usually this equipment is being used as the first equipment in a series. If you are using more than one equipments in a series for the control of air pollution in a same industry, at that time we have to use this is the first equipment to control the air pollutants, because it will helpful to remove the larger size particles. It is going to be help to remove the larger size particles. Usually the 15 micron particles can be smaller than 15 micron particles can be removed by using the gravity settling chamber. So that's why this equipment is used as the first equipment. So once again I will repeat about this gravity settling chamber. Important 2-3 points. The first point, this equipment is used for the removal of particulate matter or the dust, not for the gas. Second one, I want to remind you that this equipment can be used as the first equipment in a series, because this is used to remove the larger size particles. So the further equipments we are going to study, these will remove the smaller one particles than this one. So you can remove the larger size particles at the start. That is the first equipment you can use. This equipment is applicable to remove the particles smaller than 50 micron. So this important you should remember. So what advantages you feel with respect to this equipment? It's a low initial cost, just you have to construct with the bricks and cement. Only you should take care of the proper dimensions. Low initial cost, and there is no any moving part, so there is no maintenance. No moving part seems no maintenance, is it? Then the next one is this equipment is having very simple structure. It is having a very simple structure. This can be used only. This can be used for the dry air. This dry air can be applied for the treatment in a gravity settling chamber. Now, what are the disadvantages with respect to this? Disadvantages, I would like to tell you. The first disadvantage is it is applicable only for the larger size particles. Larger size particles. Okay, further one more point I would like to explain here with respect to this figure. So this I have made little dirty. I will take something different color pen. Further, if you want to reduce the velocity of particles I am saying, not the velocity of gas. Velocity of gas we can keep content. We can keep the cotton curtains in a hanging position. So when the gas is coming, laden gas is coming, the particles will strike on the wall of this hanging, and it will starts falling down in a hopper bottom. So this way we can increase the efficiency of particles or efficiency of settling chamber. So this is about the gravity settling chamber of the bag filter. Sorry, gravity settling chamber. Thank you.